Hello everyone, welcome to my class. I am back with a new video. Today I am going to start a new chapter which is refraction through prism. So let's go to the topic. What is prism? Prism is a transparent medium. What is the meaning of transparent? Means through which the light can pass. Now this prism is a transparent medium which is bounded by 5 surfaces, whereas the 2 are triangular and 3 are rectangular. So which one is triangular? This ABC and DEF. These 2 are triangular surface, whereas the ADEB, EBCF and the base EBCF. These 3 are the rectangular surface. Okay. Now in this prism, these 2 rectangular surface, which one? This ABED and ADFC. These two rectangular surfaces are the refracting surface. Means when the light falls on this surface, it will pass through the another surface. These 2 are called the refracting surface. Which one? I have said it. Okay. Now these 3 rectangular surfaces are inclined with each other. Here if we take these 2, means these 2 refracting surfaces which are inclined at an angle A, this A angle is called, or whatever be the angle you can take, this angle is called the angle of prism. Okay. So now we did these 2 means ADFC and ADEB. These 2 are the refracting surfaces. Means in one medium, in one surfaces, when the light will fall from this surface, means from ADFC surface, the light will come out. Okay. Here I have chosen the front faces only. Means this angle is called the angle of refraction, angle of prism. And here see, this side also the refracting surface and this side also the refracting surface. So now by this diagram I will show how the refraction occurs in the prism. See, we have read when the light comes from rarer to denser medium, then it suffers refraction, it undergoes refraction and it bends towards the normal. Now see, when the light falls on the surface, so at the point of incidence you have to draw the normal. Now the surface is like this, so the normal will be also like this. Okay, this is inclined, so inclined means normal will be this one, this angle will be 90 degree. Okay, that's why this type of normal I have drawn, means this angle will be 90 degree. Now what we have read, when the light comes from rarer medium to denser medium, then it undergoes refraction and it bends towards the normal. So this is the ray, and this is called the refracted ray. Now see, in between the prism, the light will follow one path. The direction will not change. And why? Because when it enters into the prism, the speed of light remains constant. We know when the light travels in a particular medium, in that medium the speed of light is constant. When it was in air, then the speed was constant 3 into 10 to the power 8. When it enters into the prism, then the speed of light is constant 2 into 10 to the power 8. Okay, so that's why this refracted ray will travel like this. Now again we can say, here this is the second surface, so here you have to draw the normal. Now draw the normal over here. Okay, now see, here what will happen. Now in this case the light is going from denser to rarer medium, so it will, here also it undergoes a refraction, but the light will move, light will bend away from the normal. Okay, now come to the angle. This angle is called the angle of incidence at the first surface, and here this is R1 I am giving, which is the angle of refraction at the first surface, and this is called the angle of emergence. Okay, and this angle is also R2 I am giving, which is the angle of incidence at the second surface. Now I have drawn here parallel, that I will explain later. See, in one condition this line will be parallel to the baseline, but in other cases it may go like this or like this. Okay, but now I have taken it parallel. There is also an explanation why when this refracted ray will be parallel to the base. That I am coming. Now think about, this is the refracted ray and this is the emergent ray. Now one thing you see, if in absence of prism, the light should travel in this direction. Okay, this is the original incident ray path in absence of the prism. But because of this prism, it undergoes refraction. Now this angle, see, in absence of prism, the light should travel in this direction. But because of this prism, it is shifting up to this much. So we can say this is the deviation of this ray. This is, I am giving delta 1, which is the angle of deviation at the first surface. Now when the rays comes over here, then in absence of this surface, it should travel in this direction. But because of this surface, it undergoes refraction. That's why it is bending away from the normal. So here we can say how much it deviates. This much is the angle of deviation. So here also we can say, if we increase this one, then this angle will also be this angle. So here is also delta 2. And this is the angle of deviation for the second surface. Okay. Now if we see from here, then we will observe the ray is coming from this point, which is I am giving P. So the total angle of deviation, how much? Since in case of, in absence of prism, the light will travel, light should travel in this direction. So up to how much it deviates? This much, means from here to here. Understood? From here to here. So this angle is called the angle of deviation, total angle of deviation, because of this prism. Okay. Now I will derive one equation. One thing from this diagram you can see, this exterior angle, means this delta, is equals to the sum of two interior angle. Which one? Means delta equals to, we can write delta 1 plus delta 2. So write over here, delta equals to delta 1 plus delta 2. You can write by the name also. I am not giving the name, just I am explaining. See from here, this I1 and this total, it is equal because of vertically opposite. This I1 and this total equal. So we can write this I1 equals to delta 1 plus R1. So from here you calculate delta 1 equals to I1 minus R1. Similarly, we can see this angle of emergence, means E equals to, this E equals to delta 2 plus R2. Okay, delta 2 plus R2. So from here you find delta 2 equals to E minus R2. Okay. Here you put this value of delta. So delta equals to, we can write from here, delta equals to delta 1 plus delta 2. The value of delta 1 is I1 minus R1 plus E minus R2. So here I1 plus E, in some books it is, instead of E it is given I2. So I am writing E. It doesn't matter. Minus R1 plus R2. Okay, up to this clear? Now come to the figure. Here I am giving the name P, here I am giving the name Q, and I am joining these two normal and I am giving the name is N. So see, this AP, NQ, it is forming a quadrilateral. So this quadrilateral is APNQ. So we know the sum of these four angles are 360 degree. But here this angle and these angles are 90 degree. So from here we can write angle I am writing it APN plus angle of AQN equals to 180 degree. Both are individually they are 90 degree. Now from here, so the remaining part means angle A I am giving, angle N right here, wait, angle N, PAQ I am writing it, plus which one? Angle. This is angle PNQ. This total will be also 180 degree. Okay. And see, this angle is called the angle of prism, which I have written. This is A. This angle is A. So this PNQ will be 180 minus A. Up to this clear? Now consider the triangle PQ and N. This triangle QPN I am writing. Okay. See, this total angle, sum of these three angles are 180 degree. So this angle is R1, this angle is R2. So obviously we can write this angle N will be, means PNQ will be how much? 180 minus sum of these two angles, which is R1 plus R2. Again see, this PNQ equals to 180 minus A. So instead of PNQ, I can write 180 minus A. Right over here, 180 minus A. 180, 180 cancel, minus minus cancel. So it will come A equals to R1 plus R2. This is also one relation, important relation. The relation between angle of prism and R1 and R2. Now put it in this equation in delta. This will give the relation between angle of deviation and the angle of prism. Delta equals to, we can write I1 plus E minus A. This is the total relation. This relation is important. When I will solve some numericals, this formula we have to apply. Now the relation we get, delta equals to I1 plus E minus A. In some books it is written E equals to I2. So this I am writing delta equals to I1 plus I2 minus A, or whatever, this one also you can write. So from here we can write I1 plus I2 equals to delta plus A. This is also the relation. Okay. Now one thing you see, this in the case of glass slab we have seen the incident ray and the emergent ray are parallel because these two faces are parallel, means this surface and this surface. But here these two refracting surfaces are inclined at an angle which is called the angle of prism. That's why these two rays are not parallel with each other. Okay. Next heading is the factors affecting the angle of deviation, means on which factors the angle of deviation depends on. So first factor is the angle of incidence. Very important topic. How the angle of incidence, how the angle of deviation depends on the angle of incidence. See, in some experiment it has been observed that so when the angle of incidence increases, first the angle of deviation decreases, but after a certain value again it starts increasing. By graph I am showing. Suppose this is the angle of incidence and this is angle of deviation. So first when the angle of incidence is, suppose this is 10. So angle of deviation, first it was suppose here 60 degree. Okay. First here this is the point, again increase 20 degree. So the value will decrease. First it decreases. So here suppose it is, you think this is 50 degree. Okay. Again 30. Again it comes over here. Now at 40 it comes over here, and when it is the angle is 41, then again it starts increasing from here. Means the graph will be like this. Okay. Means what is the meaning? At a particular point, means this graph will not be like this. The graph will be like this, means at a particular point the angle of deviation is minimum. Means here, oh, this is 30 degree or whatever. Not for any other case it will be different, but for explanation I am taking it 30 degree. So at a certain point, at a certain angle, this angle of deviation is minimum. That may be 40, maybe 30 or 35, whatever. Means I am telling at an angle 40, at a particular angle, not is the at 42, 41, this is also minimum angle of deviation. No, at a particular angle, at 40 degree, suppose at 40 degree, this is the minimum angle of deviation. Okay, so first, when the angle of incidence increases, first the angle of incidence starts decreasing, and after a certain value, it will give a minimum value. This minimum is called the minimum angle of deviation. After that angle of incidence, again it starts increasing. Okay. Now there is some condition for the angle of minimum deviation. So what is the condition for minimum deviation? That I am explaining by the diagram. Suppose you see, this is the diagram we have drawn. This is normal, angle of incidence I1, this is I2 I am writing, and R1, sorry, this is R1, this angle will be R2. Now one thing, when the rays goes from rarer to denser medium, then it undergoes refraction, again from denser to rarer, again it undergoes refraction, but in away from the normal. Now one thing you have to read, what is, we read already, what is the principle of reversibility? According to the principle of reversibility, light means path of the light is reversible. What is the meaning of this reversible? See, one example I am telling. When the ray, this one I am expressing. When the ray comes from rarer to denser medium, it is going like this. See, if we place a source here, light is going from here, means there is also the source of light. If we place the source of light over here, then this light will follow the same path. Okay. So the explanation is, this is the reversibility of light. Means by one experiment you can do in your home. Suppose this is the water which is in the bucket. Suppose you place one torch over here, then the light undergoes refraction. Suppose the light is bending like this. So here this is the source. If you place the source, means torch light over here, then this light will follow the same path also. Okay. This is the principle of reversibility. Now first, this is the experiment I am telling. So in first experiment, the angle was suppose 10 degree. Now we will get one emergent ray. Again, increase the angle of incidence. So at a particular time, at a particular angle, if we place the source over here, suppose at an angle 40 degree, if we place the source over here, then here is also the same angle we will get. Again, means if we place the source over here, and that time we will observe the path. Again, if we place the source over here, we will observe the path which is same, which is similar. Means at that particular angle, again at that particular angle, suppose this is I1, this is the minimum case. At suppose this I1, we will get the minimum angle of deviation. After that it will increase. Again, the experiment is, if we place the source over here, we are getting the angle of minimum deviation. Means at an angle I1, we are getting the minimum, delta minimum, and at an angle I2, we are getting the delta minimum also. So obviously we can get from these two, I1 equals to I2. This is the first condition. Means this angle equals to this angle. Angle of incidence equals to the angle of emergence. Okay. This is first condition. So when these two angles are equal, means when I1 equals to I2, so R1 will be also R2. Now in this minimum case, I told I will discuss it when it is parallel. See, this is equilateral triangle, 60 degree, 60 degree, 60 degree. Now if we draw over here, one thing you see, if these two angles are equal, then obviously these two angles will be equal. Okay. So when these two angles are equal, obviously this line will be parallel with this line. Clear? So at the minimum angle of deviation, this refracted ray will be parallel to the base. Okay, so first condition is the I1 equals to I2 and R1 equals to R2. And the second condition will be this refracted ray, suppose PQ, this PQ will be, this is B, A and C, this is parallel with the BC. This is the two condition for the minimum angle of deviation. The relation was I1 plus I2 equals to A plus delta. Now at minimum angle of deviation, that I1 equals to I2, which I am writing it I. So put it in this equation. When I am putting I1 equals to I2, so I have to write this delta equals to delta minimum. So I plus I will be A plus delta. This here now you put delta min. So delta minimum equals to twice I minus A. This is the expression for the delta minimum with angle of incidence and the angle of prism. Here three diagrams I have chosen. Here all the triangles are equilateral, means all the angles will be 60 degree. This is also 60 degree. Now by experiment we have seen when the angle is, suppose here this angle is not 48 degree, this is suppose 70 degree. So when the angle is 70 degree, then we get the angle of emergence, which is the 33 degree. But how to calculate the angle of deviation minimum, that I will explain it. Minimum deviation, we read delta equals to I1 plus I2 minus A. Okay, so I1 I2 we know, so from A also 60 degree, so from here we can find out the value of delta, which is coming 43 degree. Okay, here when the angle of incidence decreases, so at an angle 48 degree, it has been observed the angle of emergence is coming 48 degree. Means here I1 and I2 is same. That's why this refracted ray will be parallel to the base. Suppose A, B and C, which all the angles are 60 degree. But here see, as I1 is not equals to I2, that's why these rays are not parallel with the base. So at a particular case, this ray will be parallel to the base. Here you can find the value of delta. See, we read when I1 equals to I2, that is the condition for minimum deviation. So we can write this is the delta min equals to 48 plus 48 minus 60. So it will come near about 36 degree. So for 48, it is the angle of minimum deviation is the 36, but the angle of incidence is at an angle 48 degree, it will give the angle of minimum deviation. Now in that second case, again if we decrease the angle of incidence, so we will observe the ray is not parallel with the base, so the angle of emergence also coming 77 degree. From this equation we can get the angle of deviation. Okay, these are the three diagrams, and here we can find out the value of R1 also. See, we read mu equals to, from Snell's law, mu equals to sine I by sine R. So here see sine R1, it is I1. So mu for glass, prism means glass, so mu is 1.5 equals to sine I1 70 degree divided by sine R1. So from here we can get the value of R1 also. Okay, this is all about the angle of minimum deviation. The angle of deviation depends also some another factor. Second factor is the refractive index. How the angle of deviation depends on the refractive index? See, when the mu increases, angle of deviation delta also it will increase. Why? See, and mu increases means actually the optical density is increases. So when the optical density increases, then the light will bend more towards the normal, because it is passing through the more optical density medium. That's why. So when the mu increases, then the angle of deviation also it will increase because of the more bending. Okay, and next number 3, angle of prism. Angle of prism. Here also, when the angle of prism increases, then the delta also it will increase because of the more bending. The last case on which the angle of deviation depends on, that is the lambda. This one means the wavelength of light. See, one thing you will say, what is the definition of, what is the meaning of this monochromatic light? Monochromatic light means single color or more single wavelength. Single color light is called the monochromatic light. Now, one thing you remember, lambda means wavelength. For color, for VGR we know red to violet, which has less wavelength, that will suffer more bending. Why? So in case of violet light, we know in case of violet light the lambda is minimum. So when the lambda is minimum, one relation we read, lambda proportional to 1 by mu. So for mu, violet will be greater than the mu red, and lambda for red will be greater than the lambda violet. This relation we know. Now, which has minimum wavelength, that has more refractive index, means mu for violet will be more. So when the light, means violet light, undergoes refraction, there will be more bending. Why? Because of more refractive index. Okay, so when there is some more bending, means there will be more angle of deviation. So that's why this violet light, for this violet light, there will be maximum angle of deviation, and for red light there is minimum angle of deviation. So the relation is angle of deviation decreases with increasing wavelength. Okay, so the relation of angle of deviation is delta V. We can write delta V greater than delta R. Hence angle of deviation for the violet is more than the angle of deviation for red. This is all about the refraction through prism. In next class I will discuss some application of the refraction of light in real life. Okay, thank you.